All right, so you're looking at 2021 question, which is scattering more concept and organic chemistry. So for us to understand this question, we need first to understand the issue of esters and how to calculate percentage yield in mass to mass calculation. So under esters, let me explain briefly on esters so that we can use the same information to answer the question. So on esters, just a brief part on esters. So we understand that esters are formed when a carboxylic acid reacts with an alcohol, and each time when these two react, an ester will be produced as well as water. So this alcohol part, we have alcohol react with carboxylic acid. So if we want to form ester, we'll react these two. So the key concept here, in a quick one, the key concept is that we know that alcohol and carboxylic acid. So let's talk about propanol. So I'll get just different examples. So propanol, then here I will talk about butanoic acid. Butanoic acid. So I have propanol, all right. So if you want to form an ester, the name of an ester will come from these two reactants. So this alcohol and this acid will form the ester name. Now, if you want to make the ester name, from this alcohol part, this anode part will be changed into YL. This anode part will be converted to YL. Then the prefix will be the same. So this part is the suffix, then this part is the prefix. Therefore, we are going to form what is called now pro. So we have removed ANOL, then you're going to add YL, so it will be propyl. Then from the acid part, we are going to remove, from this part now, we are going to remove this one, which is IC. Then IC will be converted to ATE. In English, you can read as AT. So IC will be removed and we add ATE. Therefore, the prefix part will be maintained. So it will be now buta, this part, then butano. Then we add ATE. So this is called now butanate. So this alcohol and this acid, when they react, the name of the ester which will be produced now, we'll call it as propyl butanate. So that's the name of an ester which we have created. So this is how esters are formed. So the only secret part is to understand how you can form how you can change the alcohol part and how you can change the carboxylic part. Always when writing this, understand that you start with the alcohol part, then you end with the acid part. Don't do the vice versa part. So this is how we form the names of an alcohol, of an ester. Now, if we want to do this now in form of an equation, we understand that it will be like this. Alcohol plus carboxylic acid, it will form ester plus water. That is the general equation. And in most cases, these equations which are involving formation of esters, we don't normally balance them. They are self-balanced. So let's say we have the same, let me use the same alcohols. So we have propanol plus butanoic acid. We are forming propylbutanate plus water. That is how the equation will be formed. Now in form of chemical, so this is what we call the weight equation. Now in form of the chemical equation, so we understand that when propanol is on number 3, so it will be 3C3, then H, 3 times 2, it will be 6 plus 1, it will be 7. So here 7, then we add hydroxyl. This is a chemical formula for propanol. Then acid, this one number 4, so it will have 3 carbon here. Then 3 times 2, it will give us 6 plus 1, 7. Then we move to hydrogen, so it will be 5. Then we put COO as the functional group. So this OH is what we call the functional group of alcohol. So if you want to understand about how I came up with this one, we need to look at how alcohols are being written. So from here, we'll say now, we'll say C3, H5, then COO. So I can write this one in form of this, like this. Then before I put a plus, then I'll add again C3, H7, then plus H2O. So this part now is what we call propylbutanate. So what I've done is this. From this acid part, I've only removed this hydrogen. So from this part, I've removed hydrogen. As a result, you have COO. Now, in short, since I have 2 atoms of oxygen, I've just written it like this one. Then, from the acid part, from the alcohol part, from the alcohol part, I've removed the hydroxyl. Then from here, I've removed the hydrogen. So this is the reason why I've only the H7 here. So this hydroxyl has come here with this hydrogen. So this hydrogen plus this hydrogen, we have H2. Then this oxygen is this one. So this is a self-balanced equation. So this is how we write the equation, and carboxylic in the alcohol to form esters. So if you want more information about this, I will leave a link in the comment section so that you can follow the link, and then it will lead you to the full topic which I presented on esters. It's about 42 minutes, so it can help you. So having the background on this one, now we can move on to our actual question. All right, so this is the question before us. So I say, ethyl ethanol. So now you have understood how this came. So you need to understand how this came, because I've just from explaining. So this is an ester, ethyl ethanol, and here they have put in terms of the chemical what? The chemical symbol, the chemical formula can be prepared from ethanol and ethanoic acid. All right, so now they are saying write write the chemical equation for the reaction. Write the chemical equation for the reaction. Mean that you need to present now the chemical equation for this reaction, how they came up with this. Then number 2, calculate the theoretical yield. So now before we go to more concept, let's now use the same information. Looking at the ethyl ethanol. So the first thing for you to write the equation, you need to understand the two reactants. So ethyl ethanol, ethyl is coming from the alcohol called ethanol. So we have ethanol react with ethyl ethanol, react with ethanoic acid. So these are the two things which we have. So ethanol, which is a very important alcohol, so it's on number 2. If number 2, so C2H5, then hydroxyl, this is an alcohol, plus ethanoic acid, C, then CH, then the number here, it will be 2 times 2, 4 plus 1, 5, and I'm going to write 3. We remove 2 hydrogen. Then also put the functional group like this. So these are the 2 components which can be reacted to form ethyl ethanol. So I'm going to form now. Remember what I said, alcohol will lose hydroxyl, then acid will lose its hydrogen. So I'm going to say CH3, this, then I'll copy this one. So instead of writing like this, I'll just write it in a short way. I'll just put 2. Then I'm done. I will not include this one. Then I'll just copy this one the way it is. Then C2H5, then plus water, H2O. That is the chemical equation, how this was prepared. So that was the first question on the first question. So the first one, we are done. We need to 5E. So the first one, we are done. Now, as for the second one, we are saying calculate the theoretical yield of ethyl ethanol. So we are still looking at this one. So if our equation is wrong, it means that even our answer will be wrong. So for us to understand, I'll bring back my same equation. Then for the benefit of doubt, we have a number of carbons here, then we can also compare here, then we move on. So from here, the number of carbons have 2, 3, 4. Here we have 1, 2, plus 2, we have 4. Oxygen, we have 1, plus 3, which is 3. Then here we have 2, plus 1 here, which is also 3. Hydrogen, we have 5, plus 1, we have 6. Then 6 plus have 9 plus 1, we have 10. So 3, 8 plus 2, we have 10. So the equation is balanced. So equations involving esters, they are self-balanced. So this means that we have one more here. We have one more here. We also have one more here. We also have one more here. We also have one more. Like that. So under more concept, if they are saying to calculate the what? The theoretical yield, they are talking about what we call mass to mass calculation. So under mass to mass calculation, the first thing whenever using this part, you need to identify two parts which are going to equate to each other. Number one, you need to move out one thing which they are asking you to calculate. Then number two, you need to get the other component or the other reactant which has the value in our equation. So in this case, we are calculating for this one. So this one, we are going to remove it. Then from the reactant parts, between alcohol and acid, which one are we going to get? So that we can equate this to this one. So for us to get that one, the first thing to understand is that we don't just guess which one to get. We need to go back to the equation. So from the equation which we have, they are saying, calculate the theoretical yield of ethanol. So we are looking for this one. We are going to take that one, which can be obtained from 23 grams of ethanol. So this is where the question lies again. So we know that we are looking for the mass of this one. And this one, ethanol, it has a value. So I'm going to get this one and this one. If this 23 grams was for ethanoic acid, then we need to get ethanoic acid. Now, because it has come with ethanol, we are going to get ethanol. Therefore, I'll say one more of ethanol. So C2H5OH, 2, one more of CH3CO2, C2, then H5. That is the first part to equate. So after this step, the next step is to calculate. So how are we going to calculate? We're going to do something like this. I'll drop this one more here. So I'll just say one more times. Then the next thing is to find the mister of this one. So mister meaning that I will find the relative molecular mass. So I'll just do the calculations directly. So what I mean is this. I have C2H5 then OH. So hydrogen 1 times 1, then oxygen here it is 1 times mass number 16, then hydrogen I have 1 times 3 here, I have not 3, it's 5 there, then carbon I have 2 times 12. So if I do my calculation, 2 times 12 is 24, so 24 plus 16 plus 5 plus 1. So I'm getting 46. So you have 46 grams per mole. Okay, so this part we are done. Then I'll come this side, one more. Then I need also to do the same thing there. So there, I know that carbon has 12, mass number, there is no number here, so it means there is 1. So 1 times 12, it is 12. Then plus hydrogen, I have 3, plus carbon again, I have 12, plus carbon again, or oxygen, I have 16. 16 times 2, I have 32. Or what I've done here, since I have 2 atoms of carbon, one I've said times 2. Or if you want, you can say 16 plus 16 is one and the same thing. Then plus carbon, there's 2 here, so 2 times 12 mass number. So you have 24 plus 24, then plus 5. So I have 88. So times 88. Then, so grams per mole. So step by step. Then what else? What can I do next? Remember that I want the mass of this one. So here I'll put X. Since I'm looking for the mass of this one, then I'll create this one. Ethanol, it has 23 grams. So 23 grams. Then I'm going to cross multiply. So gram and the gram can go. Moles and moles can go. So all the units here have cancelled. Then what else? So more and more can go. We have many grams there. So we'll say now X is equal to, so this times this one. Now we know that 1 times 46, it is 46. Then we also know that 23 times 88 grams over, here it has 46, so over 46. So what are we going to get? We have 23, we multiply by 88. Then the answer we divide by 46. So I get him 44. So X is equal to 44 grams. So that was the mass which was required for us to calculate. So any questions, you can just rewind the video, you pause a bit, after you understand, then you play again, you move like that. So this is how the mass was being calculated. So this explanation is very simple. I'm very cool. I'm not fast today, so that you understand. This is more concept. Then the next part, they are saying, the next question they are saying, if 33 grams of ethyl ethanol is produced. So if 33 grams of, so this is what we call the actual yield. The actual has been given. Of ethyl ethanol is produced. Calculate the percentage yield. Calculate the percentage yield. So percentage yield is calculated as this. Percentage yield is equal to actual yield over theoretical yield, you multiply by 100%. So since we have the actual yield from the question, the actual yield is 33. So we'll say now 33 grams. Therefore, then theoretical is the one we have calculated, 44. So 44 grams, then we multiply by 100%. So this and this will cancel. So my answer now, will be like this. So we have 33, we divide by 44, then percentage 75. So 75. So we are saying percentage yield is equal to 75%. So the production was good. It gave us about 75%, then 25% was lost due to some circumstances. So this is how the question was going. So if you have noticed that the question, you can get the question wrong just from the first one. So if you fail to write the correct chemical equation, it means you fail to balance. When you fail to balance, this question 2, how to come up with your HOD to give a wrong answer, automatically if that wrong answer, if that one is a wrong answer, then also C will be a wrong answer. Then for the last one, it's just direct. To which homologous series does ethyl belong? So it belongs to, so the question D, it belongs to esters. These are esters. That's all. So that is how the question was. If there are any questions, any clarification you want, please you can leave a comment in the section below. Then we'll follow it up and redo or correct it. Thank you so much for watching. That is the video which you requested me to do for you. So we'll meet in another discussion.